Hello, it's Josef De Pfeiffer, and I'm super excited to be joined today by Nicolas and Anton from Alva Industries. Alva Industries is a global motor manufacturer based out of Norway, and today we're going to be discussing all things Alva. We're going to be looking at different types of motors, different applications for motors, and also talking about the company's patented and groundbreaking fiber printing technology. Nicolas, could you start by providing a brief overview to yourself?
Yes, sure. Thank you. I'm Nicolas Giraudo. I'm the Chief Commercial Officer at Alva, joined in March 2024 to be part of a change of strategy, which is going into precision in motion by producing frameless motors, but not only. And I'm very excited to be part of Alva today.
Thanks. And how about you, Anton?
So I'm Anton Franzén. I'm the Director of Product Management and Application Engineering here at Alva. I've been with the company since 2018, so that's more than 6 years now. I'm a mechanical engineer by education, and I'm here to support our customers finding the right solution for their application.
Could you tell us a bit more about Alva?
Alva is a motor and designer and manufacturer located in Norway, in Trondheim more specifically. At the beginning, Alva was doing mostly technology, and technology means our very exclusive fiber printing technology. But recently, we went through a strategy change to bring products to the market, and now we are focusing on the design and manufacture of frameless motors that can be used as direct drives and as in geared mechatronics.
And what are the main products and solutions that Alva offers?
So right now we are bringing to the market a whole series of frameless motors as a standard products, but that doesn't stop there. Our technology has been proven to be excellent for many applications. So besides our standard products that are supposed to be a demonstrator of what our capabilities are and can be used for fast prototyping, we can also design and make new custom designs with a lot of flexibility, and that characterizes us as being very flexible in our designs.
Alva talks a lot about slotless motors. For those that perhaps haven't heard this terminology before, could you provide a quick definition?
Yes. So slotless motors compared to iron core motors doesn't have slots. So a slot is basically where you traditionally wind up your copper. But a slotless motor doesn't have any iron teeth, so there's nowhere to wind up the copper. So therefore, there's no slots. So they're literally slotless, these type of motors.
And is it not true that the slotless motors can typically output less torque than the slotted motors?
That's definitely true for traditional slotless motors. So the constraint you have with traditional slotless motor is that you don't have iron teeth to concentrate the magnetic field into the air gap. Secondly, since you have to basically put all the copper within the magnetic field when you don't have any slots, is that you have to have a manufacturing method that allows you to compact the copper really tightly within the magnetic air gap. And there hasn't really existed any good manufacturing processes for that. But that's where fiber printing comes in. The key difference between fiber printing and other manufacturing methods for slotless motors is that we can maximize the copper fill factor within the air gap of the motor. So traditionally, yes, it hasn't been possible to do torque dense motors that are slotless, but today with fiber printing, you can.
Makes sense. Could you talk a bit more about some of the main benefits that slotless motors provide?
Of course. So there's two main benefits of slotless motors. First of all, you have no cogging. No cogging means that you don't have the asymmetric interaction between the stator and rotor that you traditionally have in an iron core motor. That asymmetric interaction means that the motor literally cogs when you turn it. So you don't have a linear torque output. Secondly, you don't have any saturation. Saturation is when you get too strong of a magnetic field in your iron teeth, which limits your maximum torque output. In slotless motors, you don't have any teeth that can saturate, so the motor is not limited by this, which means that the relationship between torque and current is extremely linear, and your peak torque is way higher than a traditional iron core motor.
Question for you, Nicolas. What are some of the main applications where you see slotless motors being used successfully?
We like to say that the potential is endless. There are so many applications, and we're discovering applications every day. The most obvious application for slotless motors that have absolutely no cogging, they are very thin and very light, are of course precision gimbals that can be applied to defense applications, metrology, commercial applications, and so on. And other applications that are extremely popular are medical applications like surgical robotics, exoskeletons, and the like. We also have a lot of traction in applications that require thrust, like thrusters for marine applications and UAV propulsion systems. But as I say, we are discovering new applications every day, and the potential is not limited as of today.
Yeah, so a couple of things caught my attention there. The first one is you speak about precision gimbals. What are some of the main challenges that you see engineers facing when selecting motors for these types of applications?
One popular acronym in the precision gimbals design is called SWAP, that stands for size, weight, and power. Alva technology can help in all those three things. Size, we have the thinnest motor out there, the thinnest frameless motor out there. So that can be integrated in very compact designs. Weight, we have the lightest frameless motor out there. So we can naturally help on that. And power, because of the technology and the fiber printing, we can also have a much less current required for the same amount of torque, and that also helps with the power consumption in gimbal designs.
And you also mentioned surgical robotics as an application, where I obviously have a very keen interest. What are some of the main benefits that slotless motors can bring to surgical robotic applications?
The most obvious benefit from slotless designs is being cogging free. That may not be as obvious for geared applications, which is the most popular case or the most common case in surgical robots. However, we heard from our customers that improves the controllability and the overall smooth motion of the robot, even though that is going through a gear. That's one thing. The next thing is, of course, being the lightest and thinnest frameless motor out there. This allows for a much more compact design of the actuator, which of course opens up a whole new field of applications. For example, customers are able to put the arms of the robot closer together, and that is very good for microsurgery, for example. And of course, the overall weight of the systems goes down, which is, of course, for robots that have to be moved around from operation site to operation site, as of course a big reason to consider lighter motors.
And am I able to compensate for cogging?
Yes, it is possible to compensate for cogging in iron core motors. Basically, you map the non-linear behavior of the motor, and then you take that information and you induce an inverted torque input, basically, to compensate for this. The issue is that the cogging that you have in the motor is dependent on many variables that vary. So therefore, you won't have a perfect compensation at all times. So it will work well sometimes, but in other situations, it won't. So in applications where you need really high precision, it's not really good enough of a solution.
Another application that you spoke about was thrusters. Question for you, Anton. Why use fiber printed motors in thruster applications?
Yes. So this is very interesting. What we've seen with our frameless motors in thruster application is that we can get really good efficiency and really good thrusts. And the reason for this boils down to that we have water and corrosion resistant active material. So that means that our motors can be directly submerged in the water. That allows us to have extremely good cooling. So we can maximize the thrust output from our motors by that. Secondly, since it's a slotless motor, our speed-dependent losses are extremely low. So it allows us to do large diameter motors, which can fit outside of the propellers of a thruster. So we can drive the propeller from the outside and therefore have a really, really long leverage arm and get a really high efficiency. So with our frameless motors, when we integrate them into thrusters, we get really high peak thrust and really high peak efficiency.
Let's talk a bit more about Alva specifically then. So tell me a bit about some of your unique selling points. What makes you different?
Alvas USPs are concentrated in the fiber printing technology that allows us to make slotless motors. And these kind of motors are the thinnest, the lightest, cogging-free frameless motors in the market. So everything related to being very light, cogging-free, and thin is part of our unique selling proposition. Now, on top of that, it's the flexibility of designing new motors. We are not only able to make these motors in a unique way, but also are extremely flexible on making new designs because there is an automated way of how we produce and design the stators or the windings that are going to a stator. That it could be a rotor as well, but in this case we are using it as a stator in the standard products. And that flexibility allows engineers to set their minds free on designing and not to have to live with all the limitations and compromises that have to be done with pre-existing designs from data sheets of slotted motors, for example. And the reason of being able to consider fiber printed motors and slotless motors from Alva as an option is because our performance is comparable or as good or even in sometimes better than a slotted design, which allows it for a much bigger frame of applications that where they can be used.
And what would you say are some of the main things that enable these USPs?
The secret of making these motors so efficient and high precision and cogging free lies on the fiber printing technology. That is the way we do our windings. But it's not only that. We also have rotors that you will believe that this is only the stator, but no, the rotor is also inside. So this is how thin they are. And these rotors are made with a technology that is already known, that is called Halbach arrays. And this allows us, the combination of these two technologies allows us to achieve this high performance and have this cogging-free technology and being as light and as thin as we are. So that's in a nutshell what allows us to have these advantages.
What do you feel makes fiber printing ideal for precision applications?
Yes. So first of all, it's a slotless technology. So you don't have any cogging and you don't have any saturation. Both of those are great for high accuracy and high precision in dynamic applications. Secondly, fiber printing allows us a much higher copper fill factor, and your windings are not skewed as traditional slotless motors. That increases the motor constant twofold, which means that your torque density also increases dramatically. So this is a precision motor that can rival iron core motors in terms of torque density. So you get both the precision and the strength that you need in dynamic applications.
So if I'm designing an actuator or a mechatronic solution, why should I consider these types of motors?
That depends on what kind of mechatronics or actuator you're designing. And if you're designing a geared solution, the typical situation is that you can either use an angle gearbox or a reduction and put the motor somewhere else, or use a frameless motor and connect it to the gearbox directly in the actuator. Typically, these designs with a frameless solution don't bring as much benefits or as many benefits to be able to make that big change. And that's why many actuator designers are not going that road. With fiber printing, we believe that because of how thin our motors are, and we're getting a lot of traction on this, the whole benefits of making a much more compact actuator will make that jump into frameless motors easier, or it will bring more benefits to it. So the design flexibility is huge, right? And if you are going direct drive, and if you're already using a direct drive without any gears, you will benefit from the cogging-free solution and making it much lighter. So many of these actuators go on top of things or have to be moved around, like for example in an XY configuration, and they have to be carried around. So being lighter is a big benefit. And also direct drives typically are used in applications that require high acceleration. And the fact of our technology that is having no saturation, we can have extremely high peak torques, which are required for these typical direct drive applications. So that is one of the main benefits of the slotless designs.
How do you typically mount these motors? Sort of how easy are they to integrate into these types of systems?
Yes. So in terms of integration and mounting the motors, what we have on the stator and the rotor is that we have aluminum ring here and aluminum ring on the outside of the stator with very tight tolerances. So it allows for easy integration to different types of housing. We recommend 3 different ways of mounting these motors. One is clamping, where you basically use screws to actually bolt down the stator and rotor. This is a really good method where you require to disassemble your application for some reason. Secondly, you can use adhesives. Adhesives are great. They give you a really strong connection. And the third one is press fitting, where you press fit down your stator and rotor. This is also great where you want to avoid having chemicals in your production lines, or you want to avoid having curing time. You just have to spend special attention when you do press fitting, because you got to make sure that your tolerances are correct for the press fit and that it works in the temperature range you're intending for your product.
If I'm a design engineer looking to test this technology quickly, do you offer house solutions that you can send on a relatively short lead time?
Yes, so we do offer house versions in the end of the year for easy testing. So if you're interested in testing these motors, but you don't want to go and spend a lot of time designing a housing for it and so on, we do offer a test kit where you can just bolt this up on your test bench. It has a integrated encoder, so you can just plug it into your motor drive and start testing.
Yeah, you just mentioned encoders. How easy is it to integrate encoders with the fiber printed motors?
Yes, the motors are very suitable to integrate with encoders. The large inner diameter of the rotor and the stator allows you to integrate large encoders with very high accuracy. If that's inductive, magnetic, optical, all of them are compatible with this technology.
And how easy is it to integrate the motors with gearboxes?
Yeah, so integration with gearboxes, that's a really interesting topic because the large inner diameter of these motors allows you to do things you haven't been able to do before. For example, you can integrate the gearbox in the middle of the motor. By doing that, you save a lot of space. You make your actuator much more compact. You can reduce the part count, and you can also reduce weight by doing that.
Sorry, I have to ask this. This does all sound great, but come on, what is the catch?
That's an excellent question. There are no really catches. There's no catch. There are things to consider, though, because this is a slotless motor, it's a slotless design. So one of the things to consider is having low inductance. And having a low inductance is great. These are low inductance motors, and it's great because it brings you benefits like controllability. If you want to run smooth speeds, it has a high response time. It has a smoother torque and all the things, but you have to be able to control it. So the control side of things has to be considered. Also, the design of the holdback array of these motors has a high number of poles. So again, on the electronics, if you want to be running at high speeds, you have to be able to run it with a certain frequency. So it's also something to consider. And last but not least, we have a design where the starter is very light. So the rotor, in respect to the starter, is a little heavier. So that has to be considered for inertia reasons. We think that that's always something that can be solved, but it has to be considered. So again, no catches, but things to consider in the design.
So a couple of the applications you spoke about earlier can be very sensitive to temperature. For these types of applications, what should engineers consider?
First of all, you got to have good cooling. No, but what's really important here is to maximize your motor constant. So the motor constant is a parameter of the motors. The motor constant determines how much losses you have dependent on your torque output. So what you want to do if you have a temperature sensitive application is that you go and maximize this motor constant. What's really good about our offering is that we do offer two versions of basically every size of motor we have. We have a lightweight option, and then we have a different configuration, which is optimized for high torque and high motor constant. So I really recommend using that type of configuration for a temperature sensitive application.
Yeah, so thank you both very much for your time today. Do you have any parting comments before we sign off?
Yes, thank you. I encourage everybody that is designing a mechatronics or thinking of design an actuator or anything that is related to motors to reach out to me, because you may be missing on an opportunity that is to rethink and design your mechatronic with a whole new technology. And I'm pretty sure that if one of the challenges that we mentioned today, like cogging, weight, compactness, or performance are one of the issues that you're having, you are gonna wanna hear from us. So please reach out. FiberPrinting is a unique technology that is only offered by Alva, and you can only get it from us, so please reach out to us.